the time? I'm going to get caught out at 11:30. My internet's really bad out here, huh? Yeah, can I want to try hotspot a phone quick. See if mine works. Let me just see if this improves on my phone. Your phone was blitz yesterday, huh? What is it? Lowercase.
Yeah.
Fuck it. I'm having troubles with the internet. What's the time? 2 minutes.
Which one's the remote to the other one? Is it this one? Okay. Thanks, guys. Yeah, in your mic tonight. Okay, cool.
Yeah, the internet's so rubbish out here. Fuck. Is your phone? Just gonna close my browser and start again. Yeah. They probably were just waiting for us to get going. But also be careful of what I say now because I'm live, apparently. It's great and scary at the same time. Okay, so we're going to open up Doc 2. On the spot, there we go. Your phone's performing really well now. Oh, what? We're almost ready to get styling.
How do you grab that one onto your right?
Okay, great. Yeah, I just want to turn this so people can see. I think we're good. We're ready to start. I think on time. Exactly. Jeff is here. No. Hi, can you all hear me all right? Great. All right, well, my name's Hayden Bradfield and I work for Drone Deploy. I'm part of the robotics team that originally came out of New Zealand. I've recently moved to Houston to spend, I guess, more time with you guys and do more events like this to get you and help you build out your robotics program, whether it's with autonomous drones or robotics. I'm basically your point of call. My colleague Jeff, he's inside and he'll probably maybe join us. But any more details that you have on Drone Deploy, we only have 30 minutes to cover quite a lot. So whatever I skip over, if something's interesting to you, come grab us and we'll go through it in a bit more detail. We weren't able to fly the drone today, obviously, because we had the restrictions with the Blue Angels. But inside next to our booth is that Doc 2 drone. Drone Deploy is specialized in dock flights or automating drone flights and creating 3D models and photogrammetry models and hosting all your reality capture for drones for 11.5 years. We do over 300 million flights a year, and we've captured nearly 2 billion images in 1 year alone, with all the customers using us around the world. To put it in context, every 15 seconds, a drone is taking off in Drone Deploy doing a mission. So every minute there's 4 of them, and that's even when you're sleeping. So it's scary to know around the world that drones are taking off all the time using Drone Deploy. So for 11.5 years, really the trusted and proven out scaled software out there for your drone program, and now in the last 3 or 4 years, really accelerating on the adoption of robotics in the industry. So if you can see my screen over on the right-hand side, this is the Drone Deploy platform. If you've used Drone Deploy before, this looks very familiar to you. I'm going to step back and try and just control a bit at the same time. But you can see here we've got basically an overhead map. This is a 3D model of this facility based on autonomous drone flight. And we've done a lot of other types of captures around with the drone as well. So whether it's a video or photo, it all ends up nicely geolocated on your map, ready for the rest of your team, wherever they are in the world, to actually jump in and do something with. We want to do the same thing with the ground robotics in a scalable way. So regardless on whether it's a human, a robot, or a drone, all your data needs to end up on the map, geolocated, ready for the team to do something with, create those actionable workings from there. Now, to fly a drone and drone deploy is really straightforward. We have, if I wanted to create a new mission, we've got a bunch of mission formats that make it easy for you to fly. In this case, we could just do a standard mapping mission. And if I wanted to map the mission over this facility, I already have that polygon. I can just modify it. It's really straightforward. And we've done all the default settings depending on the drone. So we've got a whole team dedicated to figuring out what's the optimal settings for that drone to take the best photos to create the best 3D model for you. So it's autonomously done. The settings are ready to go. And if I had that dock sitting out here now, it would be as simple as basically jumping into the dock, clicking it there. You can see it's just offline. But we'll click it on there and then we'll hit fly. It will run through the pre-checked list that you would have done or configured for your company's process. If you had your BV loss waiver, you'd be able to go through those checklists to make sure that you're obviously within your limits and within your regulations. And then you would hit the fly button, the drone will autonomously take off, execute that mission format, and when it lands, it'll then upload the data to drone deploy, ready for whatever processing that was sort of next in line. So that's how simple it is to fly the drone. If you're using any other drone, you don't want to use drone deploy for flying. If you are maybe using another Skydio drone, or if you've got data from the Elios drone and you want to load it in drone deploy and have it on your map with all your other data, you can just quickly come to the upload tab. And then we have a smart uploader where you just drag and drop all your imagery. We'll figure out what it is, whether it's a map or a 360 panoramic image that needs to be stitched together, ends up in drone deploy along with all the other data as well. So that's how the drone data works, sort of drone workflows. And then when we start looking into our ground robotics platform, like I mentioned, same sort of thing. We want the robot to go and collect data, whatever it is, whatever sensor, and it needs to end up in drone deploy in a meaningful place. So whether that's a geolocation or nested under the asset that it was inspecting, so that your teams can then go and easily find that data and do something with it. So the ground robotics is broken into 5 main steps. Real world alignment, the 360 Google Street View collection. The third one is assets and allocation. Then we generate missions, and then we also handle the data, push it into drone deploy, put it in the nice place in the map, or send it off to your asset management system so then it's actionable by the rest of your team. Step 1 is really important to us. We value high accuracy. All the drones, everything like that, highly accurate positioning on the maps. We give it to the robot as well. So around the site, there's some QR codes that the robot can recognize. And if you're used to surveying or any ground control with your drones, workflows, it's exactly the same thing. So what you want to do is we're giving the coordinates of those QR codes to the robot. The robot then can understand that. It will scale, geolocate, and rotate correctly the robot's understanding of the world. And I'll bring it up and show you exactly what that looks like. So here we go. From that drone flight that we did, and I was fortunate enough that I was able to fly last week before there were bans on the airspace. But that there's a drone flight from my drone in the robotics space, and now the robot understands where it is relative to the real world, highly accurate. The yellow line you're seeing there is the robot's understanding of the world, of how it can navigate. And we have a small piece of software. Again, Drone Deploy is a software company. We don't do anything to do with the hardware. We create software that basically rides the robot like a jockey and controls the payloads independently of the robot. The robot's really just a carrier. So the software we do is actually very agnostic, and all the workflows we try to do, we try to lift it a level higher so that it doesn't matter the type of robot you choose in the future, that we can operate with a mixed fleet of robotics, and obviously as you saw with drones. So robot knows where it is on the blue line. We can then control it in multiple ways. So really basic remote operations is very important as well. If I jumped into, to show you, there's the dock that would have been outside, all in the same platform. Someone's checking it out. We can actually spy on them. We could give him a fright and close it, and it would start beeping. Get his head out of there real quick. But yeah, I can jump into this robot, and again, remember, this is all remote over the internet. I could be anywhere in the world. We could have been controlling robots in New Zealand, but I have full control of the robot in a remote way. So it's undocked. I could use, if you're looking at my screen, I could use these clickers. I could use my keyboard if you're into that first-person driving, gaming type sort of setup. And then I've got an Xbox controller that if I turned on and activated on my dashboard, I could then use the controller, and you can map this controller as completely customizable. At the moment, it's mapped as Boston Dynamics so that you can pick up either controller and you have the same experience. But if there was a bespoke payload or workflow that you had for the robot to do, you could easily map it to a button, click that button, the robot would do it. And that could be changing a camera, taking a certain type of photo, anything like that. So our software really enables these customized workflows. Now, I emphasize that the robot knows where it is. So you can see here by the docking station, we've got our little robot standing over there. It's all real telemetry. So if the robot moves or fell over, did a handstand, in the 3D world, the robot would be doing a handstand. Everything is live. There's no simulations or animations. We're getting telemetry from every single part of that robot, and we're showing it in a meaningful way and creating the controls that allow you to do whatever you need to do. One of the main important parts of this is basically saying, all right, I don't want to drive the robot. We want to try and keep the humans away from it as much as possible. Because the robot knows where it is in the real world, it's mapped to the drone, I have visual references of it, I can then say, all right, I want you to go to this part of site. And I've just clicked on the map. The robot is going to figure out, and you can see on the map there's that green line, colorblind. The robot's actually following its best path to get to the place I clicked. At any point I could get it to intervene and stop it and then bring it back. So I'm just showing that step one that I said was very important, getting the robot to understand where it is in the real world so that we can then start doing smart things like sending it to places that actually make sense on site. Right, so robot's there. I've got a success message on my computer, and if I wanted it to come back to the home, I'm just clicking return to dock. It knows where the dock is. It will just walk back, charge itself up again, and then get ready for the next action that we're going to send it on. So that's step one. Robot knows where it is. Very important. Step two. Now, if you've used the wait for it to dock, and then we'll get onto that. Right, if you bring your attention back to the screen here, I've turned on what we call locations. So you might have different Hearst. Everything manufactured on my site by Hearst, I need to inspect it because it's all starting to rust. Whatever. I can now go and click generate, and our software will go and find every single asset that was manufactured by Hearst that the robot understands now how to look at it, with what sensor, and generate that quickly, within a minute, ready to go. Now, I've done for all the assets before, so we'll just send the robot on that mission. But now we've got a list of all the different inspections that we can go and do. And that you can delete them, you can add them. So quick to generate a new one, you can really have a quick fire list of the things you want to do. So in this case, I've got all assets, and I'm going to run that mission. Basically, the robot's got the mission on its compute, so it should quickly load in the right map. It knows where it is. It knows all the assets it's going to do, and now we're going to go and do the inspections. You saw that? All right. And off he goes. This is strange. My asset's not loading. Am I done now? 9 minutes. Jeez. It's the strangest thing. My assets aren't loading anymore since I've been outside. And it's not your internet. It's just something that's odd that's popped up. Okay. To where we are here, it might be off in the distance. Because we can visualize everything in 3D, that becomes very obvious to us. When we provided the coordinates, we basically snap it in control and it processes it to actually line up with the real world. So when you say RTK, no, we position its map, and then the robot's very capable at remembering where it is in its map, and then we convert that into a latitude and longitude based on what we call transforms. So you can convert any coordinate system to anything, provided you understand the transform. How? So we've developed like Google Drive or OneDrive for robots. I can show you if my internet's back online, which it isn't. But basically, we've got a filing system where our software goes into the storage of the robot, and we basically can toggle a folder so that it synchronizes. So as soon as the photo gets taken and we added all the metadata that we need to, we transfer it into that folder. That photo gets uploaded through to the Drone Deploy cloud services and then gets distributed wherever it needs to go. So if it's got a little metadata tag that says Cognite Data Fusion, then it'll go off to Cognite Data Fusion. Correct. In real time. At the moment, it's connected on cell service. So we've got a bunch of options. The robot can have 5G modem built into the robot. So you can just use that. Ideally, I would have just been using that, but I only have the old payloads. And those asset names exist in Drone Deploy. So what I wanted to show you was we have a list Thank you for your time. It's been but yeah, good. Thank you very much. We'll see you later. Pleasure.
Round of applause for Hayden Bradfield. Thank you, Hayden.
Thank you.
We are going to move over to the hangar building.
Sorry, I need the mic and what up for this one? It might be. I'm not too sure though. Yeah, please.
Of data, but I will come back to that later. So we have a drone that can do contact-based inspections and mostly used for some NDT, non-destructive testing. I don't know if you're all familiar with it, but probably it's a methodology of testing the materials with contact without destroying them to monitor their integrity. It's a technique that has been used for years and years, NDT, but with handheld devices. So what we're trying to solve with the drone is getting it faster and cheaper, because when you do the handheld devices in elevated structure, it takes a lot of time to mount the scaffolding, to unmount it. During that time, your plant is offline and it has a high cost. With a drone, you just go, fly it, and what takes 10 or 15 days for an inspection would take 10 minutes with the drone. So that's really one of the things we're trying to solve, making these inspections faster and cheaper. And also, of course, when you send people on scaffolding or rope access, it's a dangerous task. So using the drone increase dramatically the safety of your operations. Of course, safety has a different price point depending where you stand on the globe, but I guess in the US, it has a highest price point. So the drone itself, it's a drone that can go in contact with structure, which is kind of counterintuitive in the drone world, because we usually teach people how to avoid obstacles. With ours, you can go in contact with the structures and take the readings. So if you guys are familiar with drones, usually when you move forward with a drone, it's like a helicopter. You have to pitch the drone, which doesn't work for us because we need to be able to have completely horizontal or any angle orientation. So the way we solve that, and I will show you right away, is that we have a unique set of motors that are tiltable, that kind of decouples the drone from the motors and allows the drone to tilt in any direction, as you see on the screens right now. So this has a lot of benefits for being able to take measurements on any kind of angles, from below, from above, with any kind of angle. So that's the UT payload. If you're familiar with the UT, you just put a coupler and take the measurements. So the drone applies pressure on the surface. It takes the measurements, and then it goes away. Of course, you're seeing the measurements on the tablet, and we're going to show you that after with the live demo. And again, one of the big advantages of this drone is the ability to take measurements at angles, which is pretty unique. The other advantages of this drone, or this aerial robot, is the modularity of payloads. Right now, we have 5 different payloads, and you can see you can change them in a really quick time. We have a UT, ultra thickness measurements for measuring the thickness of metal. We have a high temperature UT that can measure on surfaces up to 500 Fahrenheit. So if you're doing a stack, for example, you don't have to turn it off. You can do it while it's online. We have a NEMAT payload, which is a kind of UT, but will help you go through corrosion buildup, so you don't need such a clean surface. We have a dry film thickness payload, which measures the thickness of coating or paints on surfaces. And then on the other side of the energy industry, we have a payload for wind turbines. So yeah, to summarize, contact-based drone, one of the competitive advantages of this drone is that it can go in contact with surfaces. It can tilt in any direction, so you can take the measurements with any kind of angles. And of course, we have sets of payload. What is important also for sure is how, so that's when you read on the ground, but what is important out of this is the data more than anything. So how do you process the data? Whenever you go flying, you just record the measurements, and then you land, you extract the data from the drone, and you can extract everything in the format of a report, where you would have the measurements that you've taken, the A scans, we're doing only A scans, spot reading, and the picture where it was taken, the GPS coordinates, and of course the coordinates relative to take off to give you a more accurate reading. Location, sorry. Some of the use cases, I mean, I'm not going to go through all the use cases that our clients are doing. So we're not a service provider. We're a manufacturer of technology, and we sell those drones either to inspection service providers that do provide inspection services to end users, or directly to end users. For example, Chevron has one of this when they have their own drone team. One of the most recurrent use cases that we have is furnaces and smokestacks. I mean, it speaks by itself. The savings are just incredible when you don't have to turn down your plant, when you don't have to build scaffolding. This was done with one of our clients, Bilfinger. I guess Ryan is somewhere around here. He's over there. I see him. And they managed to save 160K and 24 days of work to the end user. So the return investment is extremely fast. Another one of the payloads that is very useful is the high temperature UT. Like you see, this was done with Foley Specialty Services, an inspection company based out of Louisiana. And they managed to do the furnace while it was still online, thanks to this payload that we have that goes up to 260 Celsius or 500 Fahrenheit and could take about 200 measurements in less than 2 hours and inspect a 150-foot stack in less than 2 hours, which is a significant improvement in terms of rapidity of inspection. What's next for us? So I wanted to show you the video. One of the advantages of this drone is that it has different payloads, and we're continuing working on additional payload. One of the payloads we're currently developing is the pulse eddy current. For those who don't know, it's a methodology to do the metal thickness through insulation of the pipe. So there's a lot of demand for that. We're also working on a concrete integrity payload, and this was a proof of concept that we did with Shell in the Netherlands about 2 years ago. So it's not commercially available, but it's just to show you that the possibilities are limitless. We were doing some spot repairs on the tank. So the whole idea was to put a kind of grinder tool on the head of the drone. The drone would then prep the surface, and then whenever the surface was ready, we would just land the drone, change the payload, put a sprayer, and then add additional coating on the tank, and they could commission the tank for 5 years more thanks to these spot repairs. So yeah, that's about it from my side. I mean, we can go for question and answer after, but I think I've done enough talking, and I would like to see Felix take off that baby.
Very briefly, maybe, I would need all of you just to stand back here again, so we can use this area for flying. We just wanted to get you in here to not stand in the sun all the time. Thank you. Just somewhere behind the number.
plugging this.
And it's going to make contact with the open top from there and rip it very curious. Unfortunately, you can't fly with the TFR with the hand just flying around today. So can't fly over, but you'll explain.
You don't want to show the screen?
Yeah, but this one.
Okay, okay.
Touch a couple assets here. Get some readings. These assets here, very concept there. Like Johan explained, it's a very unique in nature of the way you can fly. There's no other drone like in the world that can fly like it can. You're about to see that. It's very special in the way it can get readings. It's very robust in the way it can where and how it can do it.
So it's 3 now.
Yeah, cool. So, yeah, cool. So yeah, I will hold the tablets where you take the measurements. So you have a remote control for flying and a tablet for flying that you see where the drone is going. So you have cameras on the drone. And then usually you have a level 2, level 3 entity inspector that holds the tablet and then can take the readings and save the measurements. So let's take off. Yeah, good to go. Taking off. So yeah, that's exactly what I was telling you about, the ability to tilt in any direction. So there's no other drone, like Cody was saying, that has these capabilities. We know some other drones exist for NDT measurements, but they only take horizontal reading. They don't have this ability to fly in any position. So that's really one of the benefits and one of the innovations of this drone. And as you can see, it's extremely stable. In terms of wind resistant, it can go up to 12 meters per second or about 25, 30 miles an hour when it's flying. When you're taking measurements, you need a bit less wind, so we can go up to 15, 20 miles an hour when you're taking actual measurements. So yeah, as you can see, how else can you do this kind of reading except sending some people in? Yeah, so imagine you're in a refinery, you're above the storage tank, and you just have to pitch down the drone and you can take the measurements of the roof, for example. Ups, contact interaction, then I can save the measurements. And of course, for those of you who know NDT, you calibrate the tool before flying. We have calibration blocks with different types of thickness and metal. So there's a small plate on the ground, and Felix is going to take the measurements. One of the cool features also, so it's mostly manual right now, but the last bits of flying, which we call the interaction mode, when the drone gets its contact, it's fully automated. You align the drone with the surface, you press a switch, and the drone will do a vectorized approach until the measurement points, take the measurements, and come back. So we're trying to help users make it easier to take those measurements. And another plate here. Thickness is 0.49 centimeters. We're in the metric system, but of course you can put in the imperial. You have the ability to do that with our software. Flight time is about 12 to 15 minutes per battery. It really depends on the wind conditions, but that usually allows you to do pretty good amount of readings. In 12 minutes, you can potentially do, 10, 20, 30 readings. Yeah, and you can see really the drone is super stable. Cool, thank you, Felix. Any questions? Anything we can answer? Yep. So we're going to show another payload, which is called the EMAT. EMAT stands for electromagnetic acoustic transducer. It's another way of taking the metal thickness, but you don't have to prep the surfaces as good. It can read through corrosion buildups or, yeah. Yeah. So that's the kind of surfaces with the EMATs. You can do that. With the UT, it would be a bit harder. You would have to prep the surface before taking the reading.
Like on the TV?
Probably, yeah. Yeah.
So you just have to click to the screen briefly once it comes up.
So yeah, as you've seen, it's super easy to change the payload. It takes like 30 seconds to change the payload and then another 30 seconds to restart the drone. So let's go for the corroded plates. Now you can see the readings on the screen, 0.35 millimeters. And this has tons of application in, any kind of industry, oil and gas for sure, storage tank, furnaces, any kind of asset where you need to do the thickness inspection. But it also has application in steel mills, petrochem, chemical plants, cement factories. The possibilities are really limitless. Cool, perfect. Thank you, Felix. And feel free to come and touch the drone if you want to touch the drone. Feel free to ask questions. We're here to help. It could potentially if you develop a payload for biting. Pretty cool, huh, to see it in action, huh? Yeah, yeah. So we have, yeah, it starts at 50K until 120. And we have different options.
It comes with
both those.
it comes with one of the payloads, or
Yeah, so the first package is just with one payload for 55K. If you want the 3 payloads, it's going to be 75. If you want the 5 payloads, it's going to be 100 something. But it comes with all the
the
bells.
last one that you demonstrated can do just about anything, right? Because it doesn't have to be clean.
Exactly. What it cannot do is when you have insulation on top of the pipe. And for this, we're developing the pulse steady current payload, which is a payload to go through insulation. Yeah.
Pretty cool.
Yeah.
This is an EMAC.
This was EMAT, yeah.
Do you also have the ones with couplant?
So we have the UT with couplant, which was the first one we showed, yeah.
Oh,
We have a high temperature UT, which can go up to 500 Fahrenheit of surface. So you can do stacks while they're alive. And we have the EMAT, which, you know.
So how does it put the couplant in front of the probe?
So there's a gel dispenser, and it just pushes gel on the sensor before the interaction. Yeah. Yeah, it's here. Look.
Oh wow! So
Yeah.
you literally hook up the actual couplant bottom.
So there's just a switch, and then it will put gel on the.
So these are magnets, and it just.
No, these are not magnets.
So it doesn't really.
On this one, it's a magnet. What is keeping the drone on the surface is the motors that are tilting and applying, up to 30 newtons or 3 kilos of pressure.
And these are spring activated, right?
Yeah.
Very, very cool.
Pretty cool, huh?
It's amazing how stable it is.
Yeah, it's very stable.
What if the surface is not clean? Is there something that cleans it before it puts
No, so you have the EMAT for that.
What's the range? I mean, from flying to.
I mean, range, you could go up to, several miles, but you never do that. You're in a plane, so you usually keep the drone line of sight. Yeah. And then even when you're like, half a mile away, you don't even see the drone anymore. So, you know what I mean? So usually it's like, it's more in the 500, 600 feet that, some stacks are like 200 feet.
Okay in light wind?
Yeah, so it can fly up.
Just now joining us, my name is Casey McLean. I'm the marketing coordinator for MFE Inspection Solutions, and I will be your MC for the rest of the evening. It's my honor and my pleasure to introduce our first speaker and our first presentation, to Ms. Sterling Hayes from Skydio. So we can give him a big round of applause. He's going to go over X10.
All right. My name is Sterling Hayes. I'm a solutions engineer at Skydio. I've been lucky enough to be in the drone industry roughly 9 years to date. Yeah, been with Skydio for just about the past 4 years. So today I'm here and happy to talk about Skydio X10 and dock for X10. So Skydio has taken the forefront of being the leader in Western drone manufacturing. We have 40,000 drones shipped, 20 plus industries served, over 2,000 customers, and we do this all by producing, manufacturing, assembling, and supporting in the US. Back in December of 2022, we did launch our flagship remote operations platform for dock for X2 and S2 Plus, where we have conducted over 400 plus dock flights. 400 plus dock installations and over 73,000 flights. There it goes. So, when it comes to Skydio and what we can offer, being able to seamlessly enter into GPS-denied environments, EMF environments, congested environments in terms of traditional sensors for UAVs, we've opened the forefront in ordering a magnitude of scale across defense, transportation, oil and gas, utilities, and have defined a core fundamental approach to what previously was impossible to capture with drones. So as we all know, when it comes to critical infrastructure, maintenance is key in programs that do not stay up on the forefront of gathering new and critical insights on their infrastructure are going to be behind on preventing critical failures. Data is key, and not having the right data at the right time leads to bad decisions and results in dire consequences. Having the right data matters, and usually it's hidden in plain sight. And that's why Skydio X10 is really a breakthrough in sensor technologies. Not only do we have 6 onboard navigation cameras that are dedicated to understanding, viewing, and interpreting its environment, we offer an array of payloads and also sensor packages for Skydio X10 that range from telephoto lenses, narrow lenses, and 640 by 512 radiometric thermal sensors as well. And today I'll be talking about how Skydio dock for X10 is able to fully automate the workforce of Skydio X10 in your critical infrastructure workflows. So let's watch a quick video.
For the people with the toughest jobs in the world, having the right information at the right time is the difference between success and failure, between life and death. And every second counts. Skydio dock for X10. Station docked X10s where critical work happens. Get airborne in 20 seconds. Operate remotely from anywhere in the world and get the data you need to act. X10 features category-leading visual and thermal sensors to capture the details you need, with the modularity and versatility for any mission. Dock keeps your drones ready to fly, even in the toughest conditions. Scorching heat, freezing cold, day or night. Go beyond visual line of sight. With built-in weather sensors and airspace awareness, plus world-leading autonomy with Skydio Pathfinder to confidently get X10 sensors wherever you need them. and get limitless range with Connect Fusion. Seamless switching between point-to-point and 5G connections. Operate fleets of drones everywhere, all at once, with Skydio Remote Ops. From multi-drone operations to planning and scheduling missions for continuous data collection. For public safety agencies, Skydio DFR Command is the ultimate software suite for drone operations. Respond to incidents with a single click. Share live video with Regularly. And use augmented reality overlays for precise visual orientation. Manage your fleet, upload evidence, and build community trust. It's all at your command. Skydio Dock for X10. A fully integrated hardware and software solution from the drone to the dock to the cloud to keep our community safe, keep our lights on, and help secure our nation.
Excellent. So as you can see, over the past 5+ years, Skydio has been very busy utilizing the S2 Plus and X2 out across many different customers, many different environments, and our Pathfinder dock at the time. We have since then, as you've just seen, developed a tremendous amount of improvements, not only on the aircraft UI side and also our dock side, but have fully tailored our aircraft and docking solution for our first responders, critical infrastructure, and military and allies. This allows our communities to be safer, it keeps the lights on, and it secures our nation. And as you can also tell, there are a lot of similarities in alignments within our core verticals within oil and gas and critical infrastructure that we so desperately need to protect and keep safe and operational from a day-to-day basis. So just because the weather isn't ideal, that doesn't mean that we can't fly. So our aircraft does carry an IP rating, and so does our dock. We have built-in weather systems and ADS-B for monitoring traffic as well. So we're able to withstand, snow, wind, rain, freezing cold temperatures. And it also enables us to fly safely in total darkness or in daytime with extreme confidence. So with that being said, as I mentioned before, Skydio is able to enter into areas that previously for UAVs were quite challenging, usually unsafe to attempt with our onboard computer vision navigation system. Some of you in this crowd may have had the pleasure of joining MFE and myself in the field with Skydio, flying in and around pipe racks, potentially contested environments for connectivity, GPS signal. We can confidently get within a meter or less of a subject and capture critical infrastructure and data sets. Or with X10 now being able to capture actionable intelligence even from greater distances of high quality. Dense urban canyons, again mentioned, traditionally have been quite challenging. Again, with computer vision, onboard modeling, and real-time analysis, we're able to seamlessly operate and navigate safely. A couple specs here for everyone to see of the dock. In terms of flight time, operations, there is no downtime. We have power, connectivity, and also partners in the space to help cover any potential power losses. Our operational temperature range is quite robust in terms of a standby. And range. As you all know, range and connectivity is front and center for Skydio, and we've really developed a fantastic ecosystem that consists of both Skydio Connect access points, which are external radios that can be implemented, installed, and expanding your point-to-point Skydio connection. And also in conjunction with Skydio Connect Fusion, being able to seamlessly navigate via network, point-to-point Skydio connectivity and 5G cellular. Beyond visual line of sight is always an important topic when operating aircraft, and it is made easy with Skydio. from a hardware software standpoint, our computer navigation system provides you the best tool to fly safely in an area that you can't physically see. 6 onboard cameras provide obstacle avoidance to 1/2 inch in diameter static objects and above consistently, both during the day or nighttime using night sense. With that, we have built in, as mentioned, weather stations, ADS-B sensors, and also in-flight and pre-flight checklists that fully ensure the operator that they're going to conduct their flight safely. And that really is what is a proud point for me to bring to the conversation when regulatory could be potentially a blocker for your current or future operations that you see without using Skydio. We're able to offer professional regulatory services to help write the program documentation, operating procedures, and actually submit those waivers on behalf of your organization. Remote operations, as some of you may have seen over at our demo station over there, is also really key to expanding the use of aerial robotics in a remote standpoint. Whether you're doing pre-planned missions that are scheduled or manually executed, or potentially even leveraging our Skydio API ecosystem or professional services offering through Skydio Extend to automate those workflows. Mission planning really hasn't been easier from Skydio Dock to date. We offer KML file uploads, waypoint missions, map captures, live mission planning, and also JSON edits as well. So pretty robust in terms of mission planning capabilities to date. All of these can be edited, scheduled, repeated in real time. And also, some of you have seen here today our ReadyLink. So being able to provide your in-field insight to a broader team speaks volumes in many different situations, whether it's inspecting critical infrastructure, providing the information to the decision maker that can actually produce the correct result in a costly and time-efficient manner, or providing real-time information to an emergency response center is really critical. ReadyLink it's never been easier to share data from a Skydio aircraft before. It can be simply generated from the controller. Someone can scan a QR code, or you can generate one from Skydio Cloud that can seamlessly be shared. Data, super, super key. So, we have a fantastic tool. We're out capturing a tremendous amount of data. A lot of the value, hides behind the workflows, the insights, the post-processing, and Hugh is actually able to view, share, and analyze that. So Skydio offers an agnostic data workflow where all of our camera, meta, EXIF telemetry data is open source, and we've established a tremendous ecosystem of partners. So using Skydio Cloud, Media Sync, and our Skydio Extend ecosystem, we're seamlessly able to integrate into existing workflows today with very little to no overhead. And that provides, again, real-time analysis from the field into the right place, right time, in front of the right people when it matters the most. So, as I mentioned, some things outside of drones, drone hardware, Skydio does so much more. Not only do we offer the latest and greatest American-made drone solution, we also offer turnkey solutions in regulatory services, in-field, in-person training, professional accelerated services, and deep technical in-field support as well. Do want to thank everyone for joining us here today. I really have had a pleasure of being able to show some of you the power of Skydio and how we can really showcase some return on investment using our drones where previously, we can't think about flying in those areas. And also a huge shout out to the MFE team who has been instrumental in some of very key relationships in and around oil and gas use cases in this area. Just wanted to mention, if you have any additional questions, comments, concerns, please reach out to your MFE point of contact, and we'd be more than happy to have a deeper conversation, set up in-field time, or even a remote operations demonstration as well. So again, thank you to all participants for coming. If you would like to fly a remote operations demo, I'm over here at the booth, and we would be more than happy to enable y'all. And again, big thank you to MFE Rentals. Hey everyone, I'm Peter Stockmeyer with Flyability. I've been working with the company for about 4 years now. I've had the pleasure working with MFE now for about the same, so I wanted to thank them for having me up here today. Specifically, I'm going to be talking about our new payload, the UT payload, but also present a little background on flyability at the end as well. Going into where we differ from traditional drones, Helios 3 is powered by a system called FlyAware. So this is really a combination of computer vision, LiDAR, and essentially a graphic engine to allow the drone to know where it is in live time. Your standard drone is running off GPS. We're flying in really those areas where you can't send your standard drone. As far as the UT payload itself that we'll be talking about today, it's a payload we've gotten quite a few requests for over the years from our clientele. The Helios 3 was really our base, and we've built payloads on it since. And Q1 of this year was when we actually officially launched this UT payload. But why did we put UT on a drone? What we're traditionally doing with UT, these guys are going and building scaffolding, they're doing cherry pickers, or they're doing rope access teams. So there's really a major difference compared to flying in with a drone. It's much safer, much easier to do, and a lot quicker. The other thing is the Helios 3 is a collision tolerant drone. So it's really able to hit into a wall, make contact with the surface, and stay flying. If it somehow lands upside down, it will upright itself. So there's a lot it can do in these confined, dangerous areas. And UT is a contact-based activity. So the Helios 3 was really perfect for this type of payload. As far as what I'll talk about today, we have a few different features that make the UT payload able to operate in these environments. We'll talk about location tagged UT measurements, the smart couplant dispenser, and then the probe arm and how that works and operates. As far as some use cases, I'll cover 3 use cases today. First one being tank inspections. So this is one of our most popular use cases with the UT payload. Typically you have API 653 inspections needing visual inspection as well as scaffolding inspection and UT inspection every few years. With the drone, you're actually able to eliminate most of that scaffolding costs, have a much safer time doing that, and then also limit your downtime. The tank doesn't have to be online, so you can get your plant operational much quicker. Really wanted to highlight safety here. The drone is built on the base of keeping people out of confined space, so flying inside these confined areas is much safer, much quicker, and you're not going to have to send personnel in there like you do with these traditional UT methods. Going into the UT probe arm itself and how we designed it. So the probe arm you see on the front of the drone can actually adjust to different angles. You're manually adjusting this, but here are 6 of just a few of the angles, so you can mount it on the bottom of the drone, the top of the drone, and really put it at any angle you need to get these UT measurements. As far as flexibility in this probe arm, we do go through a lot of complex environments, so we wanted it to be flexible. If you had a rigid arm there, it could impact the stability on the drone, impact how we fly. So the spring-like mechanism allows it to really fit into tight spots, ductwork, manways, and things of that nature. You can see the spring here coming into play and really what it does for the drone. If this were rigid, it would probably flip the drone over. So just a part of the UT payload design that we thought of as we were in the testing to make this system. As far as how you're seeing where the UT payload is, some of you guys flew it today. We do have a laser that's guiding this system. So you can see here on how small a pipe we can actually get a UT ultrasonic thickness reading. We're able to actually guide in with that laser. That red part is called a probe hood. So it's actually essentially able to be changed out depending on the size of your pipe, on the size of your asset. As far as our software and how you're viewing the data, we have our own software called Inspector 5. So you're able to visualize where you are inside the asset, as well as your pictures and any video data all in one area. You're also able to see that UT data in the same platform. So we have an A-scan here you can see, as well as the actual thickness reading, and able to actually localize where your UT measurements were taken, and actually make measurements as well in the point cloud. So really the reason we're using LiDAR with the system in addition to the UT is for localizing exactly where they were. If you need to go back in a report and showcase to your inspectors where these UT measurements were taken, how high up in the asset, you're able to do that very easily with LiDAR. As far as a video of what it looks like flying live, you can see here our cockpit application, and then you're going to see the A-scan graph. So while you're flying, you're able to really get a thickness reading. You can continue to build out where you are inside a tank like this, for example. Another use case coming into play that's really big for us is cargo tanks and ballast tanks. So this is in the maritime sector when ships are dry docked or have to be inspected. They typically need class surveys. So class surveys are inspected by class societies. There's a few of them: ABS, American Bureau of Shipping, Lloyd's, DNV. So all these class societies essentially regulate how these inspections in the maritime sector are going to work, specifically in these tanks. And like oil storage tanks, you have the traditional method of scaffolding or rope access. To scaffold a tank like this, it can cost hundreds of thousands of dollars. With the Helios 3 and the UT payload, you really can avoid that cost. A lot of times these guys are at height in these tanks, taking UT by hand. With the drone, you can simply fly up to the angle you need and really take it much quicker. You're avoiding work at height as well as the confined space entry, and you're getting accuracy that's tracked forever in the system. So compared to how the guys are doing it now, is they're just writing on a piece of paper and going on to the next measurement. So cargo tanks and ballast tanks are the biggest ROI you're seeing with the UT payload, and you also have a very big safety aspect there as well. Talked a little bit about LiDAR. Here's another visualization of that. So you can see exactly where in the pipe we're taking these UT measurements and know what the system is doing. Know where you can see the white line is actually the trajectory of the drone. So once you put that into a report, you can share that and know exactly where you were taking or what height those UT measurements were taken at. As far as the probe itself on the front of this payload, so we offer 3 different probes. You have the 2 megahertz, the 5 megahertz, and the 7.5 megahertz. So depending on your use case, you would use a different probe. For the thick walls, dirtier surfaces, you're using the 2 megahertz. Our most common is the 5 megahertz UT probe, and then you have the 7.5 for thin walls and similar circumstances. I talked a little bit about the probe hood. That's the red part on the front. So it's how you connect to the metal. There's magnets, as you can see on that, and that will just connect you to the steel or any metal you have. You can also take stainless steel readings. It's just not going to connect automatically with those magnets. A couple more use cases digging into how Helios 3 can improve safety, especially time. This is with an inspection company based in Brazil doing a rig inspection. So traditionally, having to inspect these tanks, 63 tanks, it took them 3 months. With the Helios 3, they were able to do it in 2 weeks, so 14 days, much quicker. They didn't have to put the personnel in the tank, and it was a lot more efficient in operation. Another use case video from a ballast tank that I can play here as well. You can see just how many chambers these ballast tanks have, and traditionally they have to monitor these monitor the air, check for poisonous gases inside these scaffold, or where harnesses for rope access. The drone can fly into these chambers much quicker, much safer manner. And this is just kind of showcasing what the UT can do in ballast tanks. We've recently been working with the American Bureau of Shipping, and they've endorsed this technology to be able to fly in ships across the globe. They also share the same sentiment of worker safety, so really trying to avoid confined space entry, work at height. And that's why they are really getting behind drone technology, especially that's going inside these areas. So you can see UT measurement here inside a ballast tank. We've done quite a few projects with ABS at this point, but any inspection company can actually get certified by ABS, Lloyd's, DNV to be certified for class hull gauging with the UT probe or for visual inspection. One more use case from a company, Texco, in the UK. So traditionally, they would actually have to do 7 to 10 days per tank. With the Helios 3, you can do 2 days per tank. This wasn't an FPSO, so it's an offshore ship platform. So just another use of the LiDAR, the visual inspection, showcased with the Helios 3. Last use case I wanted to cover is stack inspections. So steel chimneys inspections also have to be inspected every year, and you typically send in a rope access team, or you can scaffold in if it's big enough. With the Helios 3, you really can avoid those scaffolding costs. You save downtime, so the plant doesn't have to be offline as much, and then you're not working at height like a rope access team is. So just an example of what the Helios 3 is doing. We're also using the UT payload, if the stack's metal, to get readings, where they traditionally would do it via rope and with a handheld UT meter. People ask us a lot of times about surface prep. What if it's rusty? What if there's dust covered over the area where we're trying to take the UT measurement? We did develop a cleaning module. So it's essentially a tool you connect onto the front of the drone. It has a brass brush, and it will rotate in a daisy-like motion. So just a video showcasing what that looks like here, and how that motion looks like. It's not going to take off full-scale rust, but you can at least prep your surface, go back, mount the probe, and continue on with your UT inspections. Where you're using the LiDAR there is you can tag exactly where those measure or cleaning was taken, and then go back to that spot to take your UT readings. The gel and couplant is seen on the side of the Helios 3. You always know what level it's at. It's a smart couplant dispenser, and you can really put any gel into that Helios 3 system. The backbone behind the UT payload that we developed was 5 years of research and development. So we've tried the UT payload on our old model, the Helios 2, with some prototyping. It wasn't a stable enough drone. The Helios 3 was really the platform for that. So we've been testing this all over the globe. We have 3 patents on it as well, and then 100+ missions in the field. Even some of the people in this room, including MFE, helped us test it. So it has a very rigorous process before we officially launch this UT payload. A little background on who we work with at Flyability and some of our bigger customers, but now we have over 1,100 customers, 45+ resellers. You have 3 directions looking at the drone: inspection companies, you have asset owners themselves, and then government entities, things like municipalities or federal agencies. In total, we're not just in the oil and gas sector, the maritime sector. We're in a variety of industries. So you can go into cement, power generation, especially nuclear is a big one where the drone has success in, and infrastructure and utilities, underground mining, and even sewer systems as well. Over 2,000 drones
And his job is to go find leaks in this facility. He's got pipes and valves and flanges and all sorts of things. He's got to go find leaks in this place. So I'll tell you what, we'll come back to him in a little bit, see how he does that. So presenting leaks, a solution to leak detection sort of presupposes that there is a problem. So I took a look at it. It didn't take me long, to be honest, to find some pretty startling data about what a huge problem leaks are. So first I took a look sort of forward, right, towards hydrogen leaks. Hydrogen is becoming a bigger and bigger part of our fuel economy. There's a lot of fancy graphs here, but the important part to take a look at is on the bottom right. Currently, or close to currently, in 2020, the projected losses from hydrogen leaks are $30 billion. And as we move forward in 30 years, they're projecting that to basically double, $59 billion. The reason that is going to grow that fast is partly because just increased use of hydrogen as a fuel, but they also project that the equipment that we begin to use will expand and the relative leakiness of that stuff will be worse. So $60 billion in losses, and that's in a single year. You can go to the next one. So here we're taking a look back rather than a look forward. Everyone's favorite subject of leaks is methane. This was a study that was done looking back about 10 years and costs related to methane leaks. This isn't talking about greenhouse gas emissions, any of those kinds of economic considerations or environmental considerations. This is all about the financial losses, actual lost gas, value of gas, damage to other assets from possible explosions or things that happen as a result of those leaks. So this was a $4 billion loss over those 10 years. In our world today, we talk about billions pretty easily, so I went to look at what $1 billion looks like. That's not four, that's just $1 billion there. Those pallets are about 6 feet high, those are all $100 bills. Billions of dollars, is a lot more than we typically can sort of even fathom. We can go to the next one. So the last one I wanted to look at was more of a concrete example, looking years down the road, years past, entire industries and such. But this one, we have a saying at Christ, we talk to them about finding and fixing their air leaks. People say, well, it's just air. It's not dangerous. Air is cheap. You say, yeah, air is cheap, but compressed air is not cheap. Compressed air costs money. So this is not even a single company. This is a single plant, one plant, a steel mill. So they did leak testing. They found over 600 leaks. Now that worked, and it cost them about $70,000. But if you look at the big figure at the bottom right, annual savings as a result of those leak detection and repairs is over $300,000 per year. I think that's money we can all relate to, right? A single plant, a single survey, fixing the leaks, and that's the money we come up with. So I think as a result of looking at these two statistics, we can all agree, we did beforehand, that gas leaks are a big problem. Right? Yeah. So every good salesman, when you want to start to propose a solution, and it may be different from what's being used today, you say, well, how do you do that now? Right? I took a look at 4 of the most common methods that we're using today to find leaks. And none of these are bad. They all have their own advantages and disadvantages. So first, we take a look at Snoop. Snoop is essentially soapy water squirted out in a squirt bottle. Sometimes they add some glycerin to make it bubble a little bit better, but it's a great technique, right? It's 100% conclusive. If you spray that stuff on the leak, it'll bubble. So you know you have a leak. It can be used on any gas. It's very cheap. As you can see, I'm not going to read all these bullets, but the major sort of challenge with Snoop is that you have to be physically close to the target. You have to get up close and personal and squirt the Snoop onto the area. So you have to be close to it, and you have to be smart enough, fortunate enough to actually squirt it on the place where the leak's coming from. Right? Okay, go to the next one. So Snoop or Snoop. So snippers are TVA, toxic vapor analyzers. Again, they're small, they're light, they're relatively inexpensive. Some can actually tell you the gas. Speciate is the fancy word. But like Snoop, they have some shortcomings. Again, you have to actually put the sniffer into where the gas is leaking, so it's not that difficult to miss the leak. You have to be close. It can be sort of tedious and time-consuming. Again, good solution, but limited. Go to the next one. So PD loss, short for tunable diode lasers, a little bit more sophisticated instrument for finding leaks. They basically use the energy from a laser that's directed into an area where you suspect a leak. And the energy from the laser will excite the molecules of the gas enough so they can be seen with the instrument. So it's a good tool. It's good for distance measurement. In other words, you can shoot these lasers from a long distance away. But once again, similar to the other two previous methods, you have to actually kind of sort of know where the leak is to direct your laser into the right spot. And unlike the other two, this technology is limited to hydrocarbons because of the absorption characteristics of hydrocarbon gases in the infrared spectrum. So it's good technology. Again, has some pluses and minuses. And then last is everyone's favorite, OGI, short for optical gas imaging. This is a wonderful technology. I spent 12 years with FLIR selling this technology, so it's a very good technology. Good for distance detection of VOCs. You can take videos. While I was there, and since then, FLIR's worked very hard to come up with quantification models to tell you how much gas is leaking. At this point, they do a very good job of concentration parts per million. They've got good AI models to start giving you more actual quantification, but that's still an ongoing piece of work. On the downside, it is a wind-sensitive technology because it actually measures or see the gas in a plume. This is something that FLIR documented themselves. The results that you get out of an OGI camera are very user-dependent. And what I mean by that is if you're not trained in current and continually using these cameras, your ability to find a given set of leaks will be less. And they proved this. They took experienced users and less experienced users, sent them through a test bed with several different leaks. The experienced guys clearly were better at finding more of the leaks than the inexperienced guys. Again, limited. Not just hydrocarbons, but a single camera is limited to hydrocarbons. There are other cameras that can be used to find other gases, but it's still somewhat limited because they, again, like PD loss, you have to have absorption of the infrared energy by the infrared gas at a specific wavelength. And last but not least, again, relatively speaking, they're expensive. A handheld version like this is easily a $100,000 camera, usually quite a bit more. So that's a quick roundup of. I can do this, right? Yeah. Now we're going to take a look at kind of why I'm here. So acoustic imaging. And I looked at this a couple of ways: how it works and why it works. Okay. So how it works is this, and I recognize some of you in the audience have been to my booth, and we kind of talked about this a little bit. But the short version is, we use a series of an array of microphones on one side of the camera, and in the very center, you can see there's an optical camera. What this creates for the user is a map, a location of where the leak actually is located in an XY coordinate pattern. And the reason that happens that way is because, and I've used this example today, it works like our brain and our ears work. If I snap my finger here, this ear hears it before this ear. So my brain says that must be from over here. Well, with 128 ears, each one of those microphones hears that sound at a very slightly different time. And so we can locate the leak because of that phase difference. Okay? And what we see is this. In this case, that's actually partial discharge, which happens to also emit an ultrasonic frequency signal. So we can locate partial discharge in electrical gear as well. That's the interface that you see from the user side. So that's sort of how it works. Why it works? Well, when you have a gas that's in a pressurized situation and then escapes through a leak, a pinhole, it creates a vortex. And that around that vortex, that creates an ultrasound energy, an ultrasound. The question frequently comes up, and you ask it and answer it more than once in this presentation is, so Jim, what gases can you see with your system? Well, the answer is any gas. And if you think about it, it makes sense because we're using sound. We're not using that infrared absorption characteristic that organic uses, right? So gases all sound the same when they're coming out of the pinhole. So it's gas independent. It can be air, it can be hydrogen, it can be nitrogen, it can be methane, any gas. So a little bit more on the why question. So in the top center of this image, you can see that's a leak in that plant. On the circle around the bottom, this was a plant in South Louisiana, and they sent this guy out with us with a bottle of Snoop, because they didn't really believe that we could find leaks. So when we told them there was a leak, they went over and squirted it and got the balls going. But the why it works, and specifically why does it work in a noisy environment? Because that question also comes up as well, right? And it's great. You can stand in this conference room and you can show me your little leak, and we can see it and hear it in here. But I work in a noisy plant, really noisy. How can a system that hears the leak be used in a noisy environment? The answer to that lies in the idea of the frequency of the sound. Right? The arrows on the far right, the yellow arrow, that's between 0 and 20 kilohertz. That's what we hear. The red and blue arrow, that's 20 and above. That's ultrasound. So basically, we say to the camera, don't listen to that noise down here in the audible range. Listen to the noise in the ultrasound range. Now the yellow, all the yellow noise that you see there, that's a live spectrogram that sits on the right side of the image. So we can look and see this is a very noisy environment. The blue handles there are adjustable. That allows me to select the frequency at which, and only at which, the camera will display something as a leak. So unless it's between, in this case, about 42 and 48 kilohertz, it's not going to show up. So clearly that leak was at that frequency, otherwise it wouldn't be on the screen. So I'm going to talk for just a minute about some pretty cool applications that we have with the camera. The first one is, wow, what a surprise, gas leak. And one that I like to bring out is steam, and specifically superheated steam. In this room, probably most of you know this, but superheated steam is a gas and it's invisible. When it comes out as a leak, it can be very dangerous. It can cut limbs off. And also, as I mentioned a minute ago, non-hydrocarbon gases, hydrogen, nitrogen, oxygen, and just plain old air. I just like this picture because it's a cool application of Snoop, which is a little bubble action going on. Any gas. I'm going to say that one more time. Any gas. The camera is also capable of detecting vacuum leaks because they make that same vortex around the vacuums. You can't see those leaks from quite as far away because the energy is moving in the opposite direction around that hole. You still see that. So one of the applications that's become quite popular, and we really like it, is wind turbine blades. You know, if you live in this town, you see these things driving up and down the road on the back of 18-wheelers, and they take up half the freeway. So they're huge. And any big fiberglass boats, fishing boats, sailboats, they also are composite, they're fiberglass. Part of that process involves putting that entire part inside of a plastic bag and pulling a vacuum on. Well, guess what? Those things also develop pinhole leaks in those bags. So, can you imagine being this guy? This is the world's largest wind turbine blade, seen at Westinghouse. And it's in, you can see it's in the plastic bag. So go try to find a pinhole leak in this bag with a bottle of Snoop. And I'll see you in a couple of weeks. Or, think about acoustics. So I'll finish up the application part. CPChem was generous enough to let us build a use case with them based on the experience they had in the turnaround. And again, I'm not going to read all this, but it turns out they looked at the other methods, kind of the ones we just talked about. And again, all good methods, but for various reasons, acoustic turned out to be the best choice. And you can see the reasons why there, right? So at the end of the day, they I think they ended up buying 4 cameras and rented 10 cameras to do this turnaround. And the results they sort of came up with, the one that really jumps out to me, of course, is they say 3 days of leak check time, 3 days. They don't know what days of saved time in this business mean, right? Lots and lots of hours. Yeah, you thought I forgot about this guy, didn't you? So, can you run it? So you can imagine, yes, he used acoustics. So he sees a leak, we'll go to the camera view in just a second. He sees a leak kind of far away. The best practice sort of would tell you to stand in the same spot and turn around until you find every leak that you can see from that spot. So he sees one over there. Now he's got one closer. You can start to begin to understand where that leak is, and maybe my first thought was, well, it's in that flange. It's going to keep moving around and zero in just a little bit. Yeah, it's in the flange. Well, maybe not. Maybe. Let's get a little closer. And we can use our 100% conclusive method that we talked about earlier. Snoop. That's why it was in the well, not in the flange. That's the end of my page. Is there any questions? Sure.
Yeah, so depending on the diameter of the hole of the leak, it's going to depend on the pitch. So is there a parameter that it can and cannot detect, depending on how actually wide that leak is?
Fair question. I think it's I don't know if it's depending exactly on how big that hole is, but that will affect the frequency, right? But it's still going to be ultrasonic, so it may be higher or lower in that ultrasonic range, depending on that. But the thing that really determines whether I can hear it or how far away I can hear it is the decibel level, is how much noise, and how many microphones I've got in my camera. That dictates the distance. Those two, mainly those two variables. Does that answer your question? Sort of. I don't really know the answer to that question. Anything else? Great. Thank you.
Cool. Well, I have an awesome announcement for you guys. It is 2:55, and we have an awesome vendor here called Texas Barman, and they're going to be whipping up some adult beverages for you guys. So if you want to head over there to them and grab yourself a drink, network, go visit our partners at their booths, and yeah, enjoy yourselves, hang out. We can't wait to chat with you guys. Thank you.